So we will now study how to find these extrema. Again, we draw the picture, because the picture tells us all, and we will try to infer what to do from this picture. So I draw it more or less similarly to the previous video. So we have our bounded interval of points that we may consider. And let us now look at this point, this maximum, so the point x4 from the previous video where f has a maximum. Now what do we have in such a point? Well, if we compare the values at a point a little bit to the right of x4, say x4 plus h, what happens? Well, since we have a maximum at x4, the value must be lower. So if we look at the difference between the value at x4 plus h and x4, then this one is smaller than that one, so this is less or equal to 0. But we also know that this difference is approximately equal to the difference in input values multiplied by the derivative at the point x4. And of course, if we are really on the right of that point x4. So it means that since h is positive, we have that the derivative at x4 is at most equal to 0. We can also look at the point to the left of x4, so x4 minus h, and if we compare these two values, then the value at x4 is greater or equal to the value at the point to the left of x4, and so this is greater or equal to that, so it is greater or equal to 0. Again, this difference is approximately equal to the value of the derivative at x4 multiplied by h, and since we have again chosen h to be positive, we find that the derivative of f at x4 is greater or equal to 0. Now, we have concluded that it is smaller than or equal to 0, it is greater or equal to 0, and the only way how this is both possible is when it is equal to 0. Now, a point with this property is called a critical point, and what we conclude is that we need to investigate these critical points. So let us rewrite this. So the point x is called critical, at least this is the word used in the book. In other situations we would call it a stationary point if the derivative at the point equals 0. This leads to a whole theorem, which is theorem 6 on page 234, and what we suppose is that f is differentiable on the interval where we look at. Now, we observe that if we have a point in this interval where f has an extremum, so if f has an extremum at that point, then necessarily x0, well, is either a critical point. This is the situation that we just studied, but of course, as we saw before, x0 can also be an endpoint. So there's one of two possibilities. If it's an extremum, it must be a critical point or an endpoint. Now the endpoints are easily determined, and the critical points have to be calculated. Of course, once you have these points, then the next question arises is whether each point of these critical points is an extremum, and associated how to determine whether it's a maximum or minimum. Well, it turns out not to be that hard.